Let's consider factoring polynomials. As usual, we begin with some definitions. To factor means to write as a product. To prime factor means to write as a product of prime numbers. To factor completely means to write as a product of irreducible factors. Essentially, to factor completely means to factor until you cannot factor any further. We are often asked to prime factor numbers. To prime factor 24, we begin by factoring 24 into any two factors and continue factoring until we can't factor anymore. If we write 24 as 8 times 3, we can continue factoring, replacing 8 by 2 times 4, and then replacing 4 by 2 times 2 until each factor is prime. Since we have 3 factors of 2, we can write this product more compactly using 2 cubed. This is called the prime power factorization of 24, since we have written 24 as a product of powers of prime numbers. Similarly, to factor 126, we notice that 126 is divisible by both 2 and 3, and therefore 126 is divisible by 6. In fact, 126 is 6 times 21. We can factor further by replacing 6 with 2 times 3 and replacing 21 with 3 times 7. Since all of the factors are now prime, we can write 126 as 2 times 3 squared times 7. To prime factor 1080 seems harder until we realize that 1080 is 10 times 108. Replacing 10 by 2 times 5 and 108 by 9 times 12 gets us closer to primes. 2 times 5 is already a product of primes, and we can write 9 as 3 squared and write 12 as 3 times 2 squared. Finally, we have 3 factors of 2, 3 factors of 3, and only 1 factor of 5. Now let's consider factoring monomials. To factor a monomial, we prime factor the coefficient and treat each variable base as a prime factor. As usual, examples will help to clarify. To factor 18x squared, we begin by prime factoring 18. We get 2 times 3 squared times x squared. Notice that we used x as a base factor. To factor 24x to the 5th, we get 2 cubed times 3 times x to the 5th. To factor 51x squared y cubed, we get 3 times 17 times x squared times y cubed. Similarly, to factor 34x cubed y to the 5th, we get 2 times 17 times x cubed times y to the 5th. Now let's move to factoring binomials. We will use the distributive law backwards. That is, a times b plus a times c equals a times the quantity b plus c. Instructions will be to factor. To factor 2x plus 8, we first notice that both coefficients are multiples of 2. So we can undistribute the common factor of 2. When you start to factor, it's always a good idea to check your factorization by multiplying back. To factor 3x minus 6, we notice that both coefficients are multiples of 3. So we can undistribute the common factor of 3, leaving a second factor of x minus 2. Finally, to factor 5x squared plus 45x, we notice that both coefficients, or both terms, have a common factor of 5x. We can undistribute this common factor to get 5x times the quantity x plus 9. Once we get better at noticing a common factor, we generally omit writing the middle step in problems like these.